Alright, hello, I'm Alex Klausenstock, and today I'm just going to be running through a couple of properties and the basic understanding of exponents. So to start us off, I just want to make sure we're all on the same page. I'm just going to write out what exponents actually are. So, what exponents are is essentially a shorthand for a number times itself multiple times. So let's say we have 4, and it's to the 5th power. This is essentially the same as me saying 4 times 4 times 4 times 4 times 4. Those two are exactly the same. That's the meaning. And so now I'm just going to move on to a couple of properties of exponents when in just like common use and stuff. So first off, I'm going to talk about a bit of basic multiplication. So let's say you have a times a, and let's say this one's m to the n. In this case, where you're multiplying two of the same base with different exponents, what you do is you would basically add. So this is the same as a to the m plus n. Those two are exactly the same. And so right now I'm just going to run through an example to show you how that works and get you a little bit of a understanding on like what's actually going on here. So I'm just going to implement some real numbers. So let's say it's 3 times 3, and it's to the 2nd and 4th. So essentially what this is 3 times 3, and this one is 3 times 3 times 3 times 3. Now before I actually finish this, I'm just going to go back and show you this again. So in the end, this would be essentially the same as 3 2 plus 4, and that's the same as 3 to the 6th. So now, I'm going to go back to this. So right now we just have essentially 6 3's all multiplied by each other, and that should be essentially the same as 3 to the 6th, as demonstrated up here. That's what it should be. So this, in the end, is 3 to the 6th. And that's how it works. So I'm just going to box in the actual formula just so you look at that a bit more. Alright, so I'm going to go over another example. Not another example, another property, but it's going to have an example too, just so you guys get a better idea. So once again, we have another common case. So let's say it's a over a, and it's nm. So in this case with exponents, what you do is you just have the exponents subtract from each other. So in this case, with the numerator minus the denominator, and that's your answer. And again, I'm going to run through an example. So let's say you have 3 over 3, because I like 3, and it's 3 to the 3rd and 3 to the 2nd, because I like 3. This would be the same as 3 to the 3rd minus 2, and of course that's just 3. 3 is always the answer. So now I'm going to break this down a bit and show you what I mean by this. So how this actually works is just drawing this out in not so shorthand. It's 3 times 3 times 3 over 3 times 3. Now basically what happens here is you just cancel them out, and it's 1 over 3, which is actually just 3 again. 3 is always. Alright, so I'm just going to move on again. Now, here's a little bit of a twist. So, this next property says that a to the n, the m. Now, in this case, you do actually multiply the exponents, and that is because this one does not have a base, and it's multiplied by it. So this is equal to a to the n times m, and I'm going to box that one. Alright, So basically